I am happy to have Automotive Seminars as a sponsor for the show. Now, if you're not familiar, Automotive Seminars is a diagnostic technician training company. They've got a website that there'll be a link to in the show notes. And what they offer is top-notch training to technicians like us in the field. I've been taking their training courses for years and have got a ton of benefit out of it. They've got top-notch instructors, John Thornton, Scott Shotton, Scott Manna, and every other month they've got a 2-night course that you can sign up for. Join in, ask questions, and afterwards, you've paid for the course, you can access a recorded version whenever you want. You can rewatch the class 2 years later in case you wanted some details on it, and that is a fantastic feature. So make sure to check out the website to see what courses they have available and what's coming up in the future. This podcast is brought to you by Jarhead Diagnostics. Jarhead Diagnostics manufactures in-house diagnostic equipment and storage solutions, as well as distributes for companies like Pico, ATS, and TopDon. One of my favorite tools that I've bought from Brandon and Jarhead Diag is the case for the U-Scope. If you don't have a U-Scope, you probably should, but if you have one, you got to get one of these 3D printed cases, has a magnet on it, has a full-size BNC lead that you can connect to, and it gets rid of the weak point of that scope, which is the mini BNC connection, which is pretty fragile. This case makes this thing nice and secure and makes it an even better tool than it was. So check out jarheaddiag.com. The link is in the show notes. This episode is brought to you by L1 Automotive Training and Keith Perkins. If you're looking for education on module programming, J2534, EEPROM work, key and immobilizer, electrical diagnostics, or drivability diagnostics, Keith has a website, l1training.com, that's got over 60 hours of training videos on all those subjects and more. When I first started out doing mobile, I utilized Keith's videos on module programming in J2534 in order to get my head wrapped around what I would need for the tooling, the computers, the software setups, what kind of obstacles I would be up against when I'm out there programming modules on cars. And it was a huge benefit to me. And I continue to use the training videos that he has on his website. So I strongly recommend checking out l1training.com. We have got Auto Rescue Tools and Isaac Rodell as a sponsor for this podcast. Hey guys, if you're looking for programming laptops, you want the laptop set up ready to go for programming control modules on vehicles, you need key cutting equipment, you need diagnostic tools, Isaac is your guy. Has all that stuff available for purchase, and the support that he offers along with the purchase has been outstanding. I bought some stuff from him in the past. I got my Dolphin key cutting tool from him several years back. And again, the support has been phenomenal. Helped me out along the way with anything additional I needed to make it work for me. Also, for the month of June 2023, they've got Autel updates for sale. So make sure to check that out as well. Again, that's autorescuetools.com. The link will be in the show notes. Welcome to the Automotive Diagnostic Podcast. We're going to explore ways to sharpen our diagnostic skills, find learning resources, and hear from experts in the automotive field. Hey, what's going on, automotive world? This is Sean Tipping with the Automotive Diagnostic Podcast. Thanks for tuning in for another episode today. Today on the show, I'm going to share a short case study with you. It was one I dealt with in this past week, and I thought it was pretty interesting what the problem ended up being on this truck. This was a transmission shop, and I actually go to quite a few transmission shops. When I sat down at the end of this year and I looked at, where I get called to the most out of all the shops that I service, between
all the different transmission shops that I go to, that's the majority of my work. So if you're considering getting into mobile programming or you're already doing a little bit of that, definitely seek out the local transmission shops because they seem to be doing GM truck and even front wheel drive transmissions like crazy, Ford transmissions, Nissan transmissions. There's a lot of that to go around. And of course, the programming, at least for me, gets me in the door because it's a service that they can use instead of hauling it to the dealership. But then I also get the diagnostic work as well, because a lot of times, maybe not so much in the transmission shops, to be totally honest, but a lot of times I've mentioned this before where I get called for a programming, they've replaced a module to fix a problem. Module doesn't fix the problem. Well, I'm right there. Do you want me to look at it? I got my stuff. I'll do the diagnostic and get you the fix in hopefully a quick, orderly fashion. And that's how I get a lot of my diagnostic work is offering the module programming. But I'm getting a little off topic there. Anyways, this is a transmission shop and they call me for quite a few things. And what the vehicle is a 2004 Dodge Ram 2500 3/4 ton truck. It's a big truck. It's got the 5.9 diesel Cummins engine in it as well. So they called me and they wanted to see if I could reprogram the PCM. Okay. And the PCM for this particular vehicle operates both the engine and the transmission. So that would be your powertrain control module. And on this engine, it's bolted to the side of the block. It's a diesel. Again, it's a Cummins engine. So that's where you find the PCM. And they wanted to see if I could update the software in this control module in order to fix a circuit code that they were having continually set in the PCM. And I could tell a lot of the time, when somebody calls me that unless there's a specific TSB for it, which does happen from time to time, that an update's not going to fix it. But I tell them, hey, I'll check. We'll see what's going on. And if not, I'm prepared to jump into a diagnostic. I'm just sort of preparing myself for that ahead of time. So I go in to check out this vehicle and I'm going to verify this code's in there. And what the code was a P0868. And I'll get to the definition of that because I want to point out a couple of things about the definition of the code. But P0868 in the PCM, it's the only code. Hard fault sets as soon as the key is on. You don't even have to start the engine or get the transmission spinning. This sets immediately. And it does relate to the transmission, of course. But again, we'll get to the definition of the code. So what I do is I check to see if there are any service bulletins on this particular truck for this code. There isn't, but I check the module software level anyways, and I use Tech Authority in order to find out that this already had the most updated software level that was out for this 2004 Dodge Ram. So I kind of suspected that an update's not going to fix it. And really, there isn't even an update to offer for this one. So there's nothing I can do in those regards. So I kind of had that gut feeling going into this, but I thought I'd check that out anyways. So when I get to this point, I tell the shop, okay, here's where I'm at. Do you want me to dig into this? And I've done some diagnostic work for these guys before. So they were happy to let me go at it, especially because they had been messing around with this for a couple of days. One other thing they did mention to me at this point was that the cab had actually been replaced at one point or another on this truck. The customer informed him of this. So the cab for that vehicle is not original to the drivetrain and the frame of the vehicle. And obviously, that's important to note. I want to keep that in the back of my mind. I don't know if it'll come into play or not, but I'm glad to know that. If for nothing else, the VIN that's going to be on the dashboard and the door is not going to match what's in the PCM. And that's, again, that's important when I get into this diagnostic so I know what I'm looking at. So all of the data that I looked up, all of the schematics, I used the VIN in the PCM, which is for the engine, the transmission, and what's on the frame. Now, wiring in between, I don't know. Maybe that's where an issue is. I'm not sure yet, but I'll keep it in the back of my mind. But the cab had been replaced. So now I want to look at the definition of this code. And I actually spoke with the technician on this as well. Again, this is a P0868. And if you look up a P0868 OBD2 global style code, there's different definitions depending on what's equipped in this truck. And if you know what's equipped in the truck and you enter it correctly in your service information, not a big deal. It will point you in the right direction. But here's the two different definitions for this code. One definition is trans fluid pressure low, which means like the line pressure in the transmission is lower than what the PCM expects it to be at a certain point. Okay. Wide variety of reasons for that. Low fluid, a pump issue, a pressure sensor issue, could be a circuit issue, but low. And the pressure sensor that's involved puts out a voltage to the PCM so it can measure the fluid pressure. Obviously, when the pumps are running in the transmission, it expects it to be at a certain point. If it doesn't see it there, it's going to set this code, but the sensor outputs a low voltage when the pressure is low. Okay, so you would expect the output from that sensor to be on the low side, from 0 to 5 or from 0.5 to 4.5, whatever the range is for that sensor. Now, that's one definition for this code. The other definition for this code is governor pressure sensor volts too high. Okay, and this is the complete opposite of the first code. Pressure too low, and then we have a volts too high for the governor pressure sensor. So what's the difference here? Why is there two? And I should note, with the high voltage, that's really the opposite of what that first definition said. The first definition said low pressure, which to me would indicate a low voltage, but this is a high voltage code, not high pressure, but high voltage code. Again, indicating high pressure, maybe, but if we look in the definition of the code, it actually is pertaining specifically to a circuit issue, but the opposite end of the spectrum, okay? So we're dealing with low voltage in one code and high voltage in the next. And if you look at the flowcharts for these, completely different. What is the difference though? What's going to make the difference between these two codes? It's the engine that's equipped in the truck, okay? If it's a gas engine, which came as an option for this year, it's going to be the first one where it says trans fluid pressure too low. If it's a diesel, which this one is, it's going to be governor pressure sensor volts too high. Okay, now again, if you enter the correct information into your service info, you'll get the right code. That wasn't a problem for me. Here is where the issue was for the technician, and I could see this being a problem for other techs, probably even me too. The definition in his scan tool, which I believe was a Matco style scan tool, it was that first definition. It was trans fluid pressure low. Okay. And that's basically the gas code. And this is not a gas engine. It's not a gas truck. This is a diesel code. So why it came up that way, not 100%. I was actually kind of wondering, maybe the scan tool pulled the VIN off of the chassis somehow, or maybe he entered the VIN off the chassis somehow, or maybe it's just a scan tool glitch. I really didn't look into it because I actually have a DRB3 emulator for these older Chryslers, and I was using that, and it gave me the governor pressure sensor volts too high. That was the actual definition of what we're after. Because here's what I'm trying to get at. I'm kind of drawing this out with this code definition thing here, but when I have a code, and, I had a whole episode on trouble codes and their definitions. I really want to know what am I looking at? What is the computer unhappy about that it is setting this code that has failed to monitor for whatever it's looking at? And it's a big difference if I'm going after low fluid pressure or high voltage. Yeah, they both have to do with a pressure sensor in the transmission, but we're going two different ways here, and I want to know what the code means. So just take note of, situations like this where it is possible the same code number can have two different definitions, even on the same vehicle, depending on what's equipped. So we got to make sure we're entering the right information and we're just aware that this is a possibility. But to sum it up, our code for sure is governor pressure sensor volts too high. And this is a circuit code. Again, this sets immediately as soon as I turn the key on. I can clear it, comes right back. I don't have to start the truck. This is a circuit issue. I can be pretty confident in that as we go. And I have something to shoot for here too. It's going to have something to do with my pressure sensor in the transmission, and I'm definitely going to want to look at the signal wire and see what's the voltage on that signal wire. Of course, I want to know what is too high, and the flowchart was vague at best, and system description was also kind of vague. What I was able to tell, though, is that this is, a typical 5-volt sensor where the sensor output on the signal wire, and we'll talk about the circuits here in a little bit, but the output from the sensor should never be all the way to 0 or all the way at 5. And what I mean by that, a 5-volt sensor, you'd think in your mind, okay, well, this thing could put out anywhere from 0 to 5 volts, right? Well, not quite. Most of them that we see the low end around a half a volt, could be a little bit less depending on the application, up to somewhere around 4.5 volts, maybe a little higher, again, depending on the application. But generally speaking, we don't see them all the way 0 or all the way 5 on a lot of this style of sensor. And the computer knows that, it's programmed to know that. So when it sees all the way 0 or all the way 5, or maybe even higher than 5, it's going to set a circuit code or maybe a sensor performance code saying that we're outside of the normal threshold that sensor is supposed to be outputting. And that's what my code's for. It's basically saying the voltage on the signal wire is too high for what that sensor is capable of. Okay, so, even before I tear into this, I have a pretty good idea what I am looking for, what I need to look at. All right, so let's look at the sensor, or, well, you're going to listen to me talk about the sensor here, but imagine we're looking at it. It's actually a pretty simple sensor, 3 wires. Well, actually 4. I'll talk about the 4th one, but let's focus on the 3 wires for this pressure sensor, which is located behind or inside of the pan. So I can't see the sensor yet, but it's basically attached to the valve body on this transmission. 4 wires going to it. 3 of them are for the sensor, and that is going to be power, ground, and signal. Much like a lot of other 3-wire sensors that we've seen, you can apply this to potentiometers and pressure sensors, Hall effects sensors. There's a lot of different ones that use this style, 3 wires, power, ground, and signal. Now, of course, the power can be battery voltage, but in a lot of cases in these sensors, it's a 5-volt reference. And that's what it is in this one. So we have a 5-volt reference or power going to the sensor. We have a ground going to the sensor. And then we have the signal wire that comes out of the sensor, goes to the PCM, puts out a voltage. Computer correlates that to a pressure in this case. Pretty simple. Now, I did mention there's a 4th wire on the actual physical component. The reason being is that the transmission fluid temperature sensor, which is just a thermistor, is also built in. So there's a 4th wire that's a signal wire for that temperature sensor. Okay, which means the PCM also puts 5 volts onto that wire, and then the thermistor actually shares the ground with the pressure sensor, and it's going to drop the voltage on that signal wire depending on the temperature of the fluid. Okay, so do keep that in mind that there's 4 wires going to this sensor. 3 of those are going to be used for the pressure sensor, and 1 is going to be used for the temperature sensor. Again, the temperature sensor is going to share the ground with the pressure sensor internally. It's one component that gets bolted on there. You can't actually see the temperature sensor, but it's built into this piece. But it makes my checks pretty easy because, again, at this point, I'm just focused on my pressure sensor portion, and I want to know, do I have my power, do I have my ground, and what is the signal wire voltage? I can kind of guess based on the code that I'm getting. And I should note that the data stream in the scan tool would not give me a voltage for the signal wire. Did check for that, even in the DRB3 emulator, did not have that as a data PID. Oh well, I'll just have to do some physical checks here. Not a problem. So where I go to do my first set of tests is the harness connector that is actually on the top of the transmission. And it's not the top of the transmission. It's kind of, it's on the driver's side above the valve body about halfway up on the transmission, and the plug actually goes downwards to plug into this transmission. And that harness goes up, into the harness for the vehicle, eventually goes to the PCM, but it plugs into the top of the transmission. And what happens from there is there's a sub harness, which is just another wiring harness, but it goes inside the transmission. There's an O-ring to seal it. And then there's wires actually running along the side of the valve body behind the pan, inside the pan area on the valve body. And then it plugs into all the solenoids and my pressure sensor. So I'm going to start testing here. And what I do is, without unplugging it, because I don't want to disturb anything just yet, in case that connector, maybe is the problem. I don't know that yet. I want to just check my 5 volts to the sensor. I check that. I have it at that connector. I check my ground. I have that at that connector. And I check my signal wire. And I have 5 volts on my signal wire. Okay, well, based on the information that I found, 5 volts is too high for this sensor. It doesn't expect to see, based on the service information, anything more than 4.67 volts out of this pressure sensor. Even key on, engine off, it should actually be much lower. Barometric pressure was supposed to be somewhere in the neighborhood of 0.3 to 0.6 volts. But on the high end, especially when the vehicle's off, it shouldn't see this, but on the high end of pressure, it shouldn't be able to produce more than 4.6 volts. Well, it's a solid 5 on my signal wire. Okay, so I know why the code's set. I also know at least to that connector, I've got 5 volts and I've got a ground going to this sensor, which is good, but I can't access the sensor itself just yet. So my question is, at this point, is the sensor outputting 5 volts onto this signal wire, or do we potentially maybe have a short of some sort to our signal wire that's causing this to happen? Oh, and you know what? It's a little late in the game to be mentioning this. The tech actually already did replace the pressure sensor, and he did replace the sub harness that we just mentioned in the valve body area. And then he traced the wires between the PCM and this connector where I'm at. He couldn't find any issues. So it's probably a good point to bring you up to speed on what the technician has done to this vehicle before I got involved. But when I approach something like this, I like to know that information, but I also kind of just want to start at it fresh so that I don't assume something has been checked when maybe it's not. That's where you get in trouble, is when somebody would tell you, oh, that part's fine. I checked that part. It's good to go. Well, a lot of times when I hear that, it ends up being the part that needs to be replaced. But anyways, what I'm going to do at this point is I'm going to disconnect this connector. So this would be vehicle harness, the one that goes up to the PCM, from my transmission, from this sub harness, a little plastic piece that sticks out from the transmission that we plug this into. I'm going to disconnect this. Now, again, I realize this is where, maybe my issue could be, but if it is, well, then I'm going to need to take it apart anyways to inspect. Maybe a pin fitment issue, something wrong with the connector. I don't know that yet, but I try not to disturb anything, before I do my tests, because sometimes you can fix something just by unplugging or plugging something back in. At this point, I feel good enough about doing this. So I unplug this connector. And again, would be the female side of the connector, vehicle side. So this is, again, the harness that goes up to the PCM. I'm going to do my test here. Keys on. Again, I have my 5 volts right at the front of the connector. I have my ground right at the front of the connector there. Pin fit feels good on all of these. And on my signal wire, I also have 5 volts on my signal wire. Okay. Now remember, my pressure sensor at this point is effectively disconnected. I've unplugged it. It's inside the transmission. It's not hooked up to anything. But on my signal wire, I have 5 volts. Now, here's where we got to ask ourselves, is this normal or not? And I wasn't 100% sure if this was normal or not. But here's what I wanted to do. Just to see what would happen. I don't know if this is going to prove everything to me, but I want to see what happens. So I take a ground. Actually, I took the sensor ground, which is right there, and I jumped it to my signal wire. So what I would expect to happen is that 5 volts that's present on that signal wire to get pulled down to ground, which it did. And I check out my codes in my PCM when this happens, and the high voltage code went away, but a low voltage code set. And that was actually the only code that set key on engine off, was governor pressure sensor voltage too low when I grounded out the signal wire. So I know from doing that test, well, my ground's good to the sensor, of course, because it can pull down a 5-volt reference, but I know my signal wire is intact all the way to the PCM. At least it's not open anywhere. Otherwise, that test wouldn't have worked. I wouldn't have been able to set a code at that connector. But I'm still questioning, why is that 5 volts present on the signal wire when the sensor's not even connected? Am I shorted to anything else in the circuit? And, that'd be possible. Maybe somewhere in the harness, I'm shorted to a 5-volt reference, but I'm not totally convinced of that. I didn't see any other code set when I pulled that 5-volt reference down. Again, it's possible, but I wasn't feeling like that was the direction I needed to go. Here's the reason. Some sensors, depending on the application, the PCM will actually provide that 5-volt reference, you could say, or bias on the signal wire, and then the sensor will actually pull it down. It will affect that 5 volts, but with the sensor off or the sensor not doing anything or disconnected, you might see that 5 volts present on a signal wire. We see this a lot in like Hall effect sensors where they have a pull down style circuit. The sensor will get 5 volts, it'll get a ground, but then there's also 5 volts on our signal wire. It's really common. And I can't say that I've seen that a lot on pressure sensors, but I'm thinking in my head, well, maybe this is normal. Maybe that 5 volts is just coming from the PCM to the sensor, and the sensor is supposed to be pulling this down to ground. Again, I know my signal wire is at least intact to the PCM. It's not open because I could affect it by grounding it. Maybe a potential to be shorted of 5 volts somewhere else, but I'm not going to pursue that right now. Right now, I'm actually more interested in what's going on with the pressure sensor itself. If I go that route and I find out pressure sensor is good, I'll come back to this potential short to 5 volts, but I'm thinking in my head, this is probably from the PCM. This is probably an intentional voltage that's supposed to be there. So with that, I need to drop the pan. So I talked to the tech, and he already had the pan down once or twice, and he was ready to go. He dropped that down for me so that I could access the sub harness within that valve body area, and I could access the pressure sensor as well. So what I do now is I plug that big harness back in on top of the transmission, so everything's connected again. And I want to test at the sensor. I want to see, do I have the same readings? So check my 5-volt reference to the sensor. And remember, there are 4 wires on this sensor, but I'm checking the pressure sensor portion. My 5-volt supply, good. Got 5 volts, awesome. I check my signal wire at the sensor. Also 5 volts, just like I measured at the top of the transmission. And then I check my ground to the sensor. I also have 5 volts on my ground at the sensor. That is not something I want to see. I would expect there to be a ground, obviously, but I had a ground up at the top of the transmission. I have 5 volts on my ground at the sensor. So what's going on here? Is there an open maybe between the sensor and the top of the transmission? And this sub harness is only about a foot long. It's kind of wrapped in a plastic mesh, but pretty visible for the most part. And it is new. He did replace it, which doesn't necessarily mean anything, but it was replaced. So I take a look and I don't see anything visual. So at this point, I'm going to disconnect the main harness at the top of the transmission. I'm going to disconnect the pressure sensor, and I'm just going to get out my ohm meter. And I just want to see, is this thing OL? Is it open? What's going on? And if that's the case, I'll take it apart and see if I can find where the open is. Maybe it's in a connector or something like that. Pin fit was good at the sensor. Again, pin fit was good up at the top of the transmission, but looks to me like I've got an open. I got a ground up at the top, but not at the sensor. So I do my ohm check. I find the pin on the top of the transmission, and I find the pin at the sensor. I'm OL. Okay, got an open on that wire. So I just need to find out where that is, right? But I want to do one more check with my ohm meter before I decide to tear this harness apart and try to figure out where it's open. And what I do is taking my ohm meter, and this is where an ohm meter kind of shines. I realize if you're looking at a circuit that's loaded and needs to carry current, this is not the best route. But if you just want to know quick continuity checks, set that thing to the mode where it beeps at you if there's continuity, and this will make quick work of stuff like this. And it did for this one. So for reference, on the connector on the top of the transmission that plugs into the vehicle harness, pin 3 is my ground, or should be my ground to my sensor. And that's where the ground comes in. It's actually fed from the PCM, goes into pin 3, goes through the sub harness, goes to where the ground should be on the pressure sensor. Okay. So again, connected to that wire on my pressure sensor and connected to pin 3, I've got OL. But what I did was I kept my lead on the same wire on the sensor, the ground wire. And I moved my ohm meter to all the other pins on the top of the transmission. Okay, so there's 8 pins on this connector, and I moved it to all of the other pins just to see if it checks out with any of the other pins. And it actually did. So on pin 8, it ohmed. Basically, there was 0 ohms. There was continuity. My meter beeped on pin 8. But pin 8 on that connector does not go to a sensor ground. Where does pin 8 go to? It actually goes to my fluid temperature signal wire. Okay, and we talked about that. That's why I brought that up. There's 4 wires to this sensor. 3 of them are for the pressure sensor. 1 of them's for the temp sensor. And pin 8 is actually connected to where the ground is supposed to be on the sensor. And pin 3, oddly enough, is connected to the temperature sensor wire at the sensor. So really all this is that this sub harness is pinned wrong. And I'm thinking, okay, well, this is pretty easy to fix, right? Let's just take the 2 pins at the sensor, depin them, because they're actually right next to each other on the connector, for the temp sensor signal and for the ground. And the ground, again, is shared by both the pressure sensor and the temp sensor. Let's flip-flop them. That's what I do. I take those 2 wires out of the connector at the sensor. I flip them. All right. And so now they ohm out correctly. Okay. So the ground is going to the correct spot on the sensor, and my temp sensor signal wire is going to the right spot at the sensor. This is what I'm after. This is how it should be. This aftermarket harness had to have been pinned wrong. So plug the sensor in, get everything back together. And I did verify, okay, I got a ground here now. Cool. Still got 5 volts coming out of the sensor. I'm like, what the heck? What's going on here? And I was talking to the tech, and I'm like, gosh, this doesn't make any sense. I've got 5 volts here. I've got a good ground. I'm considering, do I still have a short to 5 volts somewhere on this signal wire? Maybe I need to backtrack here. I happen to find an issue with this sub harness. But he was talking to me. He's like, I have another sensor for this thing. We ordered a couple different ones. I was like, well, let me just try this other sensor that you've got. And he had another one in a box. Because again, they'd been messing around with this thing for a while. I was like, let me just try a different one. So I did. I plug in the second sensor that he has, and now my voltage actually changes to the correct level. This is on the signal wire where I had 5 volts all the rest of the time, but it actually worked. And we actually applied a little bit of shop air to this sensor, and we saw the voltage go up and down, so that I know that this thing's responding, that it's actually putting out the correct voltage onto the signal wire the way that it's supposed to. So this is cool. It's actually working now. We had a harness that was pinned wrong, aftermarket harness, causing some issues. And wherever they got that first pressure sensor from, or maybe it was a second one, I don't know, it was not working correctly either. It was failed right out of the box. talking to this guy, this tech, he does a lot of work on transmissions. He's done plenty of these diesels. He said it's pretty normal for these pressure sensors in these transmissions to be failed right out of the box. Even from the dealership, he said he's seen bad ones. So he's not surprised on that. I was like, okay, cool. Well, this one works. So you should be able to bolt this up. And what I did was I verified the code was gone. It was no longer setting. And of course, he had to bolt the pan on and everything like that and test drive it to make sure everything else is good, but we solved the circuit issue for him. It was the fact that, number one, the aftermarket sub harness was pinned wrong. We had two of them that were flopped, and I just depinned them and flipped them over. And the pressure sensor that was in there was also failed. So what was the original issue? It's hard to say at this point. Maybe there was a failed pressure sensor in there originally. Maybe there was another issue with one of the harnesses. Really hard to say what the original problem was. Maybe it was created. I know part of it was created by putting in the sub harness, but either way, my job's to tell them, hey, this is what's wrong. This is what's going to take to fix it. And of course, we did verify that the code was gone. I didn't get a chance to test drive it, but I didn't get a call saying there's anything wrong. So hopefully everything turned out okay there. So I thought that was pretty interesting, and just wanted to share my process through that problem. I should mention as well, the cab change didn't really come into play like I thought it was going to, but again, that's why it's important to get all the information and just sort of keep that in the back of your head while you're going through things, because heck, you never know what problems something like that will present. But that is all that I've got for you today. Thanks for listening, and let's get out there and start fixing the world one car at a time.